start by understanding what is big data analysis and how do we understand what is big data. So for that, we will be using motivating examples so we can understand why data is important. Next, we will understand what is data science and big data analysis. What's the difference between them? Then big data analysis, why now? Why we never used to discuss this 20 years ago or in 1990 when the computer science was started. Then we will learn what is big data, properties of big data, how is big data changing our ways of thinking. So without wasting time, let's start. So, and for an example, if we take an example, in 2023, Mr. Oren was flying from Seattle to Los Angeles for his younger brother's wedding. He bought a ticket months in advance, expecting that he will get a very good price in that way. So he did his all calculation that what will be the benefit. So he collected the data. On the basis of the data, he decided to buy a ticket in advance. So whenever we wanted to understand what will happen in future, for that we need to understand the data, and that's why the data is important. During the flight, he asked the person next to him how much did they pay for the ticket. It turned out that the person next to him paid considerably less for the ticket, despite buying it quite a bit later. Oren then asked a few other people on the flight how much they pay for the tickets. It turned out most of them paid significantly less than him. So his assumptions was that he will get a cheaper ticket. Yeah. So he was a bit conscious about it at that time. And then when he bought the ticket, after that, he tried to do the calculation. Relationship between ticket price and time it was bought was not linear. Oren set as his mission to figure out a way for people to know whether the price they see when looking for a ticket is good or not. The goal was not to determine the algorithm by which the airline companies determine the price of the ticket. The goal was to predict whether the price will go up or down. For that, you need data. He started with the sample of 12,000 price observation he scrapped from a travel website over a 41-day period. The outcome was predictive model that was used to predict how the price of the ticket will change from the given date. The model did not understand how the price is calculated. This evolved into a startup called Faircast. It used a flight reservation database with nearly 200 billion flight price records to build and train model for prediction price changes for flight tickets. In 2008, it was acquired by Microsoft for 115 million. Later was integrated into Bing search engine and then discontinued. Now let's understand data science. And then we will learn what is big data. So data science encompasses a set of principles, problem definitions, algorithm, and process for extracting non-obvious and useful pattern from large data sets. Data science has many similarities with machine learning and data mining, but it has broader and it has both. You can say that it's a combination of data mining and machine learning. Data mining focusing on analysis of structured data. For example, it is found in relationship data spaces. Machine learning focuses on algorithms for extracting patterns from data. Data science combines these with techniques for data capturing, cleaning, transforming, and storing. Now, what is the difference between data science and big data analysis? Big data analysis refers to the process of applying machine learning techniques to discovery of knowledge in big data sets. Data science encompasses other consideration, storage, ethics. But many times the terms are used interchangeably. Some argue that data science does not necessarily deal with large data sets and is more mathematical, applying mathematics and statistics techniques. Now, what do we mean by statistics in comparison with data science? What's the difference? So, when we talk about statistics, we aim to explain the data by discovering hidden data models, that how the data was generated. Whereas when we talk about data science aims to build model to predict new data, that what the next data will point on or what will be the next data. Data science uses many statistics techniques, but its goals are different from statistics. For data science, you do need statistics, but for statistics, you don't need data science. Now, let's come back to the example which we started. So, machine learning was used to build a model that predicts how the price of the ticket will change. The model does not understand how the price is calculated. Therefore, we do not understand how the data is created. We just predict what the next data point will be. Large volumes of data, 200 billion and more flight records, are used to train the model. Now, let's take another example. Swine flu in 2009. Before COVID 19, there was a swine flu. It was spreading very quickly. No vaccine was available and no clue about how serious it can be. It was vital to predict the spread of the disease, but official government data was outdated and gathered slow. US CDC was releasing data once a week, and this data wasn't completely accurate. But Google could identify the spread of swine flu in the US. Based purely on what people search for, Google could identify states in the US in which the swine flu was widespread. Google system was built on big data analysis. So Google system relied solely on what terms were used in what locations in the queries in the search engine. Based on this, it could identify in real time where the hotspots for the disease were. Their model did not have understanding how and why the disease is spreading there. Their model only identified what is happening, not why it is happening. So what we learned from this? We learn a pattern. So what is pattern and can we extract from the data? So patterns that appears frequently in transaction, frequent patterns and associate rule mining. Products that are usually purchased together in pro shopping. Clusters of similar objects are known as clusteration. Customers exhibiting similar behavior and taste. Labels of object that is known as classification. Spam filters, medical image classification. Patterns that identify strange and abnormal event are known as outliers detection. Detection of fraudulent transaction in banks, for example. The real value comes from discovering the patterns that are too complex for humans to extract manually. So what we learned from this? Frequent pattern, associate rule mining, clustering, classification, outlier detection. Now what is big data? With the emergence of internet, the amount of data generated exploded. For example, social media, computer games, media platform, web search engine, online shopping, sensors, etc., etc. It is estimated that amount of data collected since the invention of writing up to 2003 was 5 exabytes. We collect that much data every day now.